This is the first class of Principles of Ecosystem Ecology. And today we're going to start with the overview of ecosystem ecology. Now, the first question to ask as we begin our class in ecosystem ecology is exactly what is ecosystem ecology? To answer this, we need to start with a definition. And if you look in the first chapter of the book, it's difficult to find a clear definition of what ecosystem ecology is. To begin, we need to understand that ecosystem ecology is an approach. It's an approach that we use to understand the world around us. Now, looking through the textbook for information that we could use to generate a definition of ecosystem ecology, the authors have the following text. They say, the flow of energy and materials through organisms and the physical environment provides a framework for understanding the diversity of form and function of Earth's physical and biological processes. Now that's a relatively long sentence, and there's a few elements that we can use in there to help us generate our definition of ecosystem ecology. To begin, the second half of this sentence we can cross out. It's more or less a set of text to explain why we do ecosystem ecology, and that's not going to be part of our definition. But there's also some key words in the first half of the sentence that we can use. In roughly defining ecosystem ecology, the authors talk about flow, and then they also talk about energy and materials, as well as organisms and the physical environment. In subsequent texts, they go on to say that ecosystem analysis seeks to understand the factors that regulate the pools and fluxes of materials and energy through ecological systems. Now here in this class, we're going to talk about energy and materials repeatedly, so I'm going to use parallel structure just to say that energy and materials is something that we'll emphasize. But when we look at what they describe here, they really emphasize pools and fluxes, and this is a central part of understanding ecosystem ecology. In ecosystem ecology, one of the bases of what we do is really quantify the pools and fluxes that we see in ecosystems. And this is an abstraction, of course, but this is something that you'll see over and over again, that part of what we do is break down ecosystems into pools and fluxes. Fluxes are transfers from one pool to another, so items have to start in pools and then are transferred to other pools via fluxes. Now, what we showed is relatively simple, but it can get complex very quickly. What's here is a diagram, a schematic of one of the models that people use to understand soil organic matter dynamics. This is just a small part of what an ecosystem is and how it functions, and in this model you can see there's lots of pools and lots of fluxes, but the basis is the same. If we start here, for example, here's one pool, and there's an arrow that leads to another pool. So pools and fluxes is something that defines ecosystem ecology and the approach that we use to understanding ecosystems. Now, after talking about flows and understanding that these flows really refer to our approach on understanding pools and fluxes, the pools and fluxes that we think about are really going to be energy and materials. Now, in ecosystem ecology, we have energy and materials that we're going to focus on. Energy, for example, that ecosystem ecologists study would include heat, it would include light, and really those are just two forms of electromagnetic radiation, and you can see here that there's a whole spectrum of energy that we think about, and we're going to quantify, later on we'll show examples of where we're quantifying energy going into ecosystems and then moving through that ecosystem in different ways. Lastly, it's not just about heat and light as far as energy is concerned. We're really going to think a lot about chemical energy, energy that's been fixed, for example, and we can find in different compounds. We'll trace those, quantify them in pools, and trace them through different pools and through different fluxes. Now, as far as materials are concerned, materials can represent a large number of things. For example, in the text they say that the materials that we think about in ecosystem ecology include carbon, water, nitrogen, as well as rock-derived elements such as phosphorus, and novel chemicals such as pesticides or radionuclides that people have added to the environment. Again, this is a relatively long list of things that ecosystem ecologists do study, and with the approach that we use to ecosystem ecology we include. It's not an exhaustive list, for example, but it represents some of the sets. of items that we're going to study. So for example, we can break it down into some different components. They talk about carbon, water, and nitrogen, as well as rock-derived elements. So in general, ecosystem ecologists are going to look at elements, and where they come from is a separate question. And then they also emphasize here novel chemicals, such as pesticides, and they don't necessarily have to be novel chemicals that we're going to take a look at, but we are going to take a look at different chemicals. And lastly, they also mention radionuclides. Really, here what's important to think about are isotopes, and that's something separate, not just the elements, pools of different elements, but the isotopic variations on individual elements. So if we abstract what they had said there into our definition of ecosystem ecology and understanding that approach a little bit better, we're going to take a look at elements, and we're going to take a look at isotopes, as well as molecules. And these are the three general classes of materials that we focus on. Now, as far as understanding which elements, for example, that we take a look at, here's a periodic table right here that has a large number of the elements that exist, and we don't necessarily look at all of them, and definitely we don't look at all of them at any one point in time, but we do take a look at a number of them repeatedly. So often when you look at ecosystems and people are trying to study them, there are some elements that pop up a lot, so they're going to think a lot about hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. And then in other instances, it's not unreasonable to expect in ecosystem ecology somebody to also take a look at some other elements such as lithium, sodium, magnesium, potassium, calcium. Going over to here, things like boron, aluminum, and then there's a whole set in here too that can be important for different reasons. Iron, cobalt, copper are important, zinc are important. So there's not necessarily a huge number of elements that we're going to take a look at, but it's a relatively small set, and some we look at a little bit more than others. Okay, so now taking a look at kind of the best text to generate a definition of ecosystem ecology, they talk about the flow of energy and materials through organisms and the physical environment. And as you can see, we've kind of talked about pools and fluxes, which represents flows, as well as energy and materials, and we understand that a little bit better. The last part is to focus on why they included organisms and the physical environment. Later in the text, you'll read the following sentence. They say these materials, when they're talking about ecosystem ecology, are found in abiotic pools, such as soils, rocks, and water, and the atmosphere, and in biotic pools, such as plants, animals, and soil microorganisms. Here, the key for this sentence, and really what should be abstracted, is a separation between abiotic and biotic. And in ecosystem ecology, what's important is that both are required, that we're not exclusively going to look at abiotic pools, those non-living pools. We don't exclusively look at the biotic pools and interchanges among biotic pools. We're looking at interchanges often between abiotic and biotic. And that really is a hallmark of ecosystem ecology, is taking a look at both the abiotic and the biotic together. So one thing to think about too when we're thinking about abiotic and biotic is that it can be often relatively hard to separate a pool and define it as exclusively abiotic or exclusively biotic. So for example, in a tree, if you take a look at the trunk, really this portion of the tree is just a relatively thin layer of biotic, of living tissue, and for the most part, most of the tree's trunk is relatively dead. But we're still going to consider part of that biotic pool in general. But sometimes it doesn't really matter. We're just going to, in some cases, we're just going to say trees, and we recognize that some of the biomass that we have in trees, some of the materials, the compounds, the elements, some of that's going to be more alive than others, so to speak. So don't worry too much about getting clean definitions of what a biotic pool and an abiotic pool is. More importantly, it's important to understand that we're going to talk about both, and we're going to think about interchanges between abiotic and biotic. Okay, so with that, we're almost done. We're ready to generate our definition of ecosystem ecology. Again, the authors talk about the flow of energy and materials through organisms and physical environment. And we now know that when they include organisms and physical environment, they're really thinking about biotic and abiotic pools together. So the key things that I think we should include in our definition of ecosystem ecology, it's going to be important to think about pools and fluxes, as well as energy and materials, as well as biotic and abiotic. So I think we're ready to generate our definition of ecosystem ecology. I think it's pretty fair to say that ecosystem ecology is an approach to understanding, here emphasizing that approach that we use, the fluxes of energy and materials through biotic and abiotic pools. So I think that's a pretty good definition that we're going to use here. So if you ever have to kind of step back and think about what ecosystem ecology is, understand that it's going to be an approach. We're going to think about pools and fluxes of energy and materials through biotic and abiotic pools. So again, thinking about the fluxes of energy and materials through biotic and abiotic pools. If you find yourself doing that later on, you're probably doing ecosystem ecology.